Here are some very special cases of quadratic function and their reciprocal. Okay, let's consider these functions. We'll consider f of x equals to x square, and we will consider g of x equals to x minus 1 square, and we will consider h of x equals to x square plus 1. Correct? Now, if we have these functions, can you tell me how many x-intercepts do we have here? Fx equals to x square, one x-intercept, right? Which is at origin, correct? Therefore, the reciprocal of this function, 1 over f of x, will have how many vertical asymptotes? One vertical asymptote, correct? Here, how many x-intercepts do we have? We have one x-intercept, which is at x equals to 1, correct? Therefore, how many vertical asymptotes we'll have? Just one. Here, how many x-intercepts do we have? X square plus 1. No x-intercepts, correct? Because x square plus 1 can never be 0. X square plus 1 can never be 0, right? If you get to 0, you get x square equals to minus 1 and x square root of minus 1, which is not possible, plus or minus, right? So here we don't have any x-intercept, and therefore the reciprocal of this function will never have a vertical asymptote. Is it right? So these are very special cases which we should remember. And to show you graphically, here is their graph. Let's consider this function. So if I have to graph this function, fx equals to x square, it will be something like this. Correct? And if I have to do its reciprocal, then at this point I have a 0, right? Therefore, there will be a vertical asymptote here. At 1, the value will be 1. That is my invariant point. At minus 1, also it is 1, right? That is my invariant point, right? So the reciprocal of this function will be drawn like this. So the purple shows reciprocal, which is I am writing here at present as 1 over f of x, or is equals to 1 over x square. Do you see that? That's a reciprocal function, right? Let me say Rx equals to this. Okay? Now how about the next one? G of x. Here my function will be x minus 1. That means I have a 0 at 1, right? So when I draw it, it will be kind of like this, with 0 at 1. And therefore, the reciprocal of this function will have vertical asymptote at this point, right? And if I draw the reciprocal function, it will be like this. Do you see how easily I am drawing it? It may not be exact. Well, let me change this value. Let me write this as 4 here, okay? Purposely I'm doing it because I've drawn it lower. If it was 1, my 1 will be here and that will be my invariant point. That is why I made it 4 now, okay? So that point, vertical asymptote, is at x equals to 4, correct? And so this value, if I put x equals to 0, right? If I put x equals to 0, then I get a value here as 4 square, which is 16. Do you see that? And this value will be 1 over 16. Is that okay? 1 over 16, because reciprocal of 16 is 1 over 16, correct? A very small value. So as you can see, very close to 0, okay? Now let's get into the other one. Now here, my function is x square plus 1. So it will be like x square moved 1 unit up. Is that okay? So this is my x square, and let's say this is my 1. Now if I have to do reciprocal of 1, it will be 1, right? And my function will look like this. As it goes higher, it comes, and this value, which is common, is at 1. So you note that here I don't have any vertical asymptote, correct? So these are very special cases of our quadratic function's reciprocal. Normally in a quadratic function, what you see is something like this. Generally, let's say quadratic function, let's say q of x is generally equals to, let's say, x plus 2 times x minus 3. Generally it's like this. Is that okay? In that case, reciprocal will be what? 1 over q of x will be 1 over x plus 2 times x minus 3. So we have two roots, correct? So if you have to draw general quadratic function, how should that look like? So that should look like this. It will have two vertical asymptotes, right? Well, if I put 0 here, then I get minus 6, right? And my zeros here are at 2. Let's say this is 2 and this is 3, okay? So vertical asymptote will be where? Midway, right? We'll add minus 2 and plus 3, so we get 5. And divide by 2 will give us 2.5. Sorry, add them will be, so let's do it. Minus 2 plus 3 divided by 2 will give us plus half, right? So at half, I have a vertical asymptote. Is it okay? And the value will be 2 times 3, 6. So let's say this is my graph of parabola, which represents this function qx. Well, this value is half and 6, right? Minus 6. Okay. Now, if I have to draw the reciprocal of this function, in that case, I have vertical asymptotes at the zeros of original, correct? And my minimum, local minimum will be here, which will be 1 over 6 minus, right? Correct? And if I put, this will be 6. When I put x equals to 0, this is minus 6. Minus 6, my x, y intercept. So this will be 1/6. And this will be, I have to put 0.5 here, right? So this value is 2.5 times minus 2.5, 625, 6.25. 6.25, because I have to find the value of qx at half, right? So you say q of half equals to, I'll put in here half, right? So 0.5, so it is 2.5 times minus 2.5, 0.5 minus 3, which is 6.25 minus 6.25. So 6.25 will be this point. 6.25. So this is 1 over 6.25 and this is 1 over 6, correct? So we have this kind of like this. Yeah. And here it will be something like this. So generally, you have a reciprocal of a quadratic function in this form with two vertical asymptotes, right? But these are special cases where you have one vertical asymptote or non-vertical asymptote, right? That's why I'm calling them special, right? Do you agree with me? Correct. So always remember that quadratic functions reciprocal, you get a rational function, and that rational function may have two vertical asymptotes, may have one vertical asymptote, or no vertical asymptote. So these are the examples when they have no vertical asymptote, correct? Your exercise is, I'm giving you some problems to figure out domain and range for those functions. So let me say mx, m of x equals to 1 over x squared minus 4. Find domain range for this. And then let me have another function as n of x equals to 1 over x squared plus, let's say, 4. So I'm changing it, minus to plus, right? And you have to figure out which one will have x-intercepts, which one will not have x-intercepts, okay? We also consider x minus 4 whole square, right? You can consider this function also. P of x equals to 1 over x plus 4 whole square, correct? Let me write one more for you. Let's say s of x equals to 1 over x minus 1 times x plus 1, which is x squared minus 1, okay? Okay, so try these as a practice problem. Write down the domain and range, first sketch your graph, right? And then write domain and range, and try to understand what reciprocal of quadratic function is. In each, though, there is one common property, and what is that? Horizontal asymptote is always y equals to 0, okay? So that's a common property for each, and all of them normally have a y-intercept. But is it always true? Well, the answer is on your sheet. It may not have y-intercept. Look here. Does this function has y-intercept? fx equals to x squared. We have a vertical asymptote at x equals to 0, and therefore this quadratic function does not have any x-intercept or y-intercept. Do you see that? So there are exceptions to every rule. So make a note of all this. Have a good look at the questions, correct? Here they are, and then submit your answers. If you have any problems, please write down in your comments. We will discuss it out. Okay, thank you.